number guessing game. Then add a new line. I'll place all of this code within a do while loop. Do while our guess does not equal num. We will have the user type in another guess. We'll create a prompt, standard output, enter a guess between 1 through 100. Standard input, guess. Once the user types in a guess, we will increment our tries variable by 1 to keep track of the score. Now we'll have to examine the guess versus the number. If guess is greater than num, let's display too high. I'll add a new line. Else if guess is less than num, then we'll display too low. Else, if the guess is not above the number and the guess is not below the number, the guess must be equal to the number. Standard output, correct. We'll display the number of tries. We'll display our tries variable. I'll add a new line. And I'll just add a line of text for decoration at the bottom once we exit the game. That should be everything. Let's run this. Number guessing game. I'll guess something right in the middle. 50. Too low. Okay, so the number is between 50 and 100. I'll guess right in the middle of that range, 75. Too high. Something between 50 and 75. Perhaps 62. That's still too high. 56. Too high. 53. Too low. 54. 55. All right, the correct guess was 55. It took me 7 tries. I don't really think that's too good, but it works. Okay, everybody, that is a simple number guessing game involving the use of do while loops and generating random numbers. If you would like a copy of this code, I'll post this in the comments section down below. If you're enjoying this series, please let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Well, everybody, we have a pretty important lesson today. Today, we're going to talk about functions. A function is a block of reusable code. If you ever think that you're going to use some section of code more than once, you might as well stick it within a function. Here's an example. I'll create a function to sing happy birthday. Currently, our program is within the main function. To begin the program, we call the main function. Before the main function, we can create a new function. For the time being, we're going to type void, then a unique function name. The function name should be descriptive of what it does. If I'm going to sing happy birthday, let's name this function the happy birthday function. Then add a set of parentheses, then a set of curly braces. You can see that this is almost identical to our main function, except with the main function we have a return type and return 0. What would we like to do when we invoke this function? Let's sing some of the lyrics to happy birthday. Standard output. Happy birthday to you. I'll add a new line. I'll repeat this a couple times. Happy birthday, dear you. Happy birthday to you. To invoke this function, all we have to do is within the main function, type the function name, followed by a set of parentheses. This will call, or otherwise known as invoke the function. I like to think of the parentheses as a pair of telephones that are talking to each other. To use a function, you have to call the function, call it up on the phone. So when I run this code, we have the lyrics to happy birthday. This function is reusable. I can call this function as many times as I want. I'll call this function 2 additional times. just to separate these lyrics, I'm going to add an additional new line character. Okay, we now should have 3 verses of Happy Birthday. 1, 2, 3. That's because I called the function well 3 times. A function is just a block of reusable code. Now, what a lot of people do is that they'll declare and define their functions after the main function because it's more readable to many people. But there's one issue with this. Happy Birthday was not declared in this scope. Our programs are read from the top down. Since we're invoking the Happy Birthday function before we even know what it is, well, the compiler doesn't recognize it. A solution to this is that before the main function, you can declare functions, but define them later. Let's declare Happy Birthday before the main function. Then make sure you add void, or a return type. So void Happy Birthday. We can now use this function even though it's after the main function. A lot of people like to define their functions after the main function. It's another way in which you can write it. Just be sure to at least declare them before the main function. Now check this out. What if we have a variable? Standard string name. Assign this whatever your name is. I'm going to use this name that's declared in the main function and use it within the Happy Birthday function. Let's replace you with the user's name. Happy birthday to name. I'll add a new line. Then I'll copy this, paste it, and let's change this line as well. All right, now when I run this, here's the issue. Name was not declared in this scope. Think of each function as a house. The main function is your house. Functions outside of the main function would be your neighbors, their house. Functions can't see what's going on inside of other functions. You can't see what's going on inside of your neighbor's house. You're only familiar with what's going on inside of your own house. In order for the Happy Birthday function to use the main function's name variable, it needs to be made aware of it. To do that, when you invoke a neighboring function, you can pass that variable or some other value as an argument. So within the parentheses when you invoke that function, place your values or variables. I would like to make my Happy Birthday function aware of this name variable within the main function. When you send some data over to a function, that data is also known as an argument. However, the receiving function needs a matching set of what are called parameters. If this function is going to receive this data, this name, you need a matching parameter. To set up a parameter, you first list the data type. We will receive a standard string. Then we can list a parameter name. Let's say name. Now this Happy Birthday function can use this name variable within the main function. If you have a function declaration at the top of your program, you'll have to add that parameter there as well. So Happy Birthday, standard string, and we can run this. Happy birthday to whatever your name is. Functions aren't aware of what's going on inside of other functions, but you can make them aware of any local variables or values by passing them as an argument, but you'll need a matching set of parameters. The name or otherwise unique identifier of your parameter doesn't necessarily need to have the same name, so to say. You can name it something else. Instead of naming our parameter name, let's say birthday boy or birthday girl. Happy birthday to birthday boy. And that should work the same. So you can rename parameters, but let's revert that back. Now let's pass an age. Int age equals make up some age. I would like to send my age over to the Happy Birthday function, so I will pass that as an additional argument. Separate each argument with a comma. We'll send our name as well as age. Now we need a matching set of parameters. Right now, the Happy Birthday function is only equipped to receive a name. So we list the data type, int age, and if you have a function declaration, change that there as well. Then I'll add one more line. You are age years old. Then this should work. Okay, happy birthday to whatever your name is. You are, whatever your age is, years old. So that's a function, everybody. It's a block of reusable code. If you think you're going to perform some code more than once, you can stick it within a function. Whenever you need it, you just simply call it. If you need to make your function aware of any variables, you can send them as arguments to that function, but you'll need a matching set of parameters in the function definition and the declaration. So yeah, those are functions, everybody. Your assignment is to create a unique function and post it in the comments section. And well, yeah, those are functions in C++. All right, everybody, we are on the return keyword. The return keyword will return a value back to the spot where you called the encompassing function. The return keyword is commonly found at the end of a function, much like the main function. When we invoke a function, we can return some value back. Here's an example. I'll create a function that will calculate the area of a square, but we'll need to pass in a length, the length of one side. This will be a double length, assign some value, 5.0 is good. Then we'll need to declare and define a function. At the top of my program, I'll add a function declaration. For the time being, we'll write void, but that will change soon. Void, I'll name this function square. We will square a length. List any parameters, we will accept a double value, which we will name length. Then I'll need a function definition. I'll add that after the main function. Void square. I'm going to create a temporary variable named result. It will be of the double data type. We will take length times length to calculate the area. Then I will use that return keyword. Return. What are we returning? We're returning our result. If we're returning a value, we need to change this keyword void to match the data type of what we're returning. We're returning a double, so I will change void to double. And then make sure you change that within the function declaration as well. Double square. You could do this in one line of code. You don't necessarily need to. We could simply just return length times length. That is also valid. And that's probably how I would write it. We now have this function that will calculate the area of a square once we pass in a length. I'm going to create a new variable called area. It will be of the double data type, and I will set this equal to. Then let's invoke the square function. Pass in our length variable as an argument. At this point of the program, area should be assigned a value. Let's display it. Standard output area. I'll add my area variable, then add centimeters squared, then new line. The area of our square is 25 centimeters squared, and I could change this to a different number, like 6. The area is now 36 centimeters squared. Let's create another function. This function will find the volume of a cube if we know the length of a side. We'll return a value of the double data type, but I will name this cube. We will still accept a length of the double data type. Let's copy this, paste it, change square to cube, return length times length times length. Double volume equals, we'll invoke our cube function, pass in our length, then I will display whatever the volume is. Volume, my volume variable, centimeters cubed. If the side of a square is 6 centimeters, the area would be 36. If it was a cube, the volume would be 216 centimeters. If you need to return a value back to the spot in which you invoked a function, be sure to list the data type of what you're returning. Let's try another example involving strings. I'll create a function that will add a user's first name, their last name, and create a new string called full name. Let's declare our variables. Standard string first name equals add your first name. Standard string last name equals add your last name. Then I'll create a function to concatenate two strings together. We're returning a string. I will list the data type as standard string. I'll name this function concat strings. we will have two arguments, two standard strings. Standard string. I'll name the first string string 1. Standard string, I misspelled string 2. So we have our function declaration. Now we just need to define it. I'm going to return string 1 plus, I'll add a space between the first name and the last name, plus string 2. I'll create a third variable, standard string, full name equals, I will invoke my concat strings function. Then I need to pass in two strings as arguments. I'll pass in my first name and my last name. Then let's display the full name. Standard output, hello, the user's full name. Hello, bro code, or whatever your first and last name is. So yeah, everybody, that is the return keyword. Wherever you invoke a function, you can return a value back to that spot in which you invoked that function. If you're returning a value, just be sure that you change the return type of that function to match the data type of the value being returned. In this example, I returned a string, a standard string. So the return type of this function would be a standard string. So that's the return keyword, everybody. Your assignment is in the comment section to post a function that returns some value. So yeah, that is the return keyword in C++. Hey guys, in this topic, I'm going to explain overloaded functions. In C++, and actually with many other programming languages, you can have different versions of the same function. Here's what I mean. I have a function to bake a pizza because, well, I like pizza. Bake pizza. This function will have no parameters. All I'm going to do within this function is display the words, here is your pizza. Then I'll add a new line. Then I should probably add a declaration at the top. Void bake pizza. Then to invoke this function, I would type the function name. Here is your pizza. This time I would like to bake a pizza that has toppings. Right now we just have a plain pizza with no toppings, and that's kind of lame. I'm going to create an additional version of this bake pizza method, but it's going to have different parameters. Void bake pizza. We will accept a string. Standard string. I'll name this string topping 1. We'll accept one topping as an argument. Standard output. Here is your, I'll add my topping here. Topping 1. Pizza. Then be sure to add your function declaration too. Bake pizza. Then this time we are accepting a string. It is valid for functions to share the same name, but you need a different set of parameters. A function's name plus its parameters is known as a function signature. I can bake a pizza that has no toppings. Here is your pizza. Or I could pass in a topping, like pepperoni. Here is your pepperoni pizza. Let's create an additional function that accepts two toppings. So we have topping 1, topping 2. Here is your topping 1 and topping 2 pizza. Then add your function declaration. Topping 1, topping 2. Now I can bake a pizza that has two toppings. I would like pepperoni and mushrooms. Here is your pepperoni and mushroom pizza. So yeah, everybody, those are overloaded functions. Functions can share the same name, but you need a different set of parameters. A function's name plus its parameters is known as a function's signature, and each function signature needs to be unique, kind of like an ID. So yeah, those are overloaded functions. If you would like a copy of this code, I'll post this in the comments section down below, and well, yeah, those are overloaded functions in C++. Okay, everybody, we gotta discuss variable scope. I'll explain local variables and global variables. Local variables are declared inside of a function or block of curly braces, such as within the main function or inside of another function. Global variables are declared outside of all functions. You tend to see them at the top of your program. There are some major differences between the two. Let's begin with local variables. Suppose I have some number, int mynum. mynum equals 1. If I need to display mynum, I can use standard output mynum. And of course, this will display mynum, which is 1. Now what if I have a function to display mynum? Void print num. Let's move this line of code to our print num function. I'll need to add a function declaration to the top of my program. Then we will invoke this function, print num. Okay, this isn't going to work, and here's why. mynum was not declared in this scope. Functions can't see inside of other functions. My function print num has no idea what this mynum variable is. mynum is a local variable to the main function. That's why we pass arguments to functions. We'll make the function aware of this value, but you'll need a matching set of parameters. Int mynum, then add that to the function declaration, int mynum. And this would work. That displays the number 1. But let's get rid of these parameters. It is legal to reuse the same variable name, as long as it's within a different scope. Within the printNum function, I'll also have a mynum variable that has the same name, but I'll give this a different value. When printing mynum, it prints 2. We have 2 versions of the same variable, and this is fine because they're within different scopes. Now, a global variable is declared outside of all functions. You see these at the top of your program. I will declare int mynum equals 3. I'm going to delete these 2 local variables. If I was to invoke the printNum function and print mynum, well then, that number is 3. This global variable is also available within the main function, so I will print mynum here as well within the main function. So we have 3 and 3. It's best to avoid global variables if you can, because it pollutes the global namespace. Also, variables declared within a function are much more secure, because like I said, functions can't see inside of other functions. If we had both local and global variables, mynum within the main function will be 1. Within the printNum function, it will be 2. If I was to display mynum for both of these, I'm going to add a new line to each of these. New line, and new line. A function will use any local variables first, before resorting to any global variables. That's why our printNum function prints 2, and the main function prints 1. If you'd rather use the global version, you can use the scope resolution operator. So precede your variable name with 2 colons. That is the scope resolution operator. I'll do that here as well. In place of using the local version of mynum, we will use the global version. And we will print 3. We're using the global version of mynum instead of the local version. So yeah, that's variable scope. Local variables are declared inside of a function, or anytime you see a set of curly braces. A variable declared inside a set of curly braces is hidden to the outside world. A global variable is declared outside of all functions, and is accessible to all functions within the program. Like I said, you should try and avoid using global variables if you can, because it pollutes the global namespace, and these variables are less secure. So yeah, that's variable scope. Hey, if you're enjoying this series, let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this topic we're going to create a banking program for practice. We'll be able to deposit money, withdraw money, and show a balance. This is more or less just for practice. Let's begin by creating our functions. Void show balance. There will be one parameter, double balance. Whatever our bank account balance is, we'll show it. The return type is double. Deposit, no parameters. Double withdraw, and there will be one parameter, double balance. Let's fill in a few things within the main function. Double balance, and I will go ahead and set this to 0, as well as int choice. I will set that to 0 as well. We'll use a switch to determine if the user wants to show their balance, make a deposit, a withdrawal, or exit. Let's display some output, some prompts. Standard output, enter your choice. And I'm just going to add some text decorations because I think that'll be cool. Maybe a bunch of asterisks. And one more. Okay, we have option 1. 1, show balance. 2 will be deposit money. 3 is withdraw money. 4 will be exit. Then we'll accept some user input. Standard, input, choice. Now we're going to create a switch. We're examining the user's choice. Switch. We're examining our choice against many matching cases. We have case 1, case 2, 3, 4, then a default case. Okay, case 1. The user wants to show their balance. We'll invoke the show balance function, but we need to pass in our balance. Balance. And then we are going to break. Case 2, the user wants to deposit money. So we're going to take our balance equals balance plus our deposit function. So deposit will return a double right here. So we're going to add that to our balance once we verify it. Actually, we can shorten this to balance plus equals whatever value is returned with the deposit function. Then we are going to break. Case 3, withdraw money. Balance minus equals the withdraw function, pass in our balance. We're withdrawing money from our balance once we verify it. Then we're going to break. We'll exit with case 4. I'll display some output. Standard output. Thanks for visiting. Then I'm going to break. Okay, default case. Standard output. Invalid choice. Okay, now we're going to place all of this code within a do-while loop. Do all of this while some condition is true. So let's take all of this code, cut it, put it within that do-while loop. Let me just format this a little bit. The condition will be while choice does not equal 4. 4 is what we use to exit. We'll need to add some function definitions, but I'm going to fill these in later. We'll need to return something, so let's return 0 for the time being. For 2 of these functions at least. Return 0. Okay, let's run and compile this just to test our do-while loop. Okay, enter your choice. 1, show balance. That doesn't show our balance yet, but it will. Deposit money, withdraw. Now we should be able to exit by pressing 4. Thanks for visiting. Okay, so we know that the do-while loop is working. Let's fill in our functions. Let's begin with show balance. Now with the show balance function, we're receiving our balance as an argument. So I'm going to display standard output your balance is $, or some other currency if you choose. I'll display our balance, then add a new line. So let's say we have $123 in our account. I'm going to show my balance. $123 even. But I would like to display cents. I'll need 2 decimal places after the decimal. So there's one thing we can include. We'll include this header file. Include IO man IP. There's a function in here to set some precision for floating point numbers. I'm going to make this change after the $sign. Standard set precision, pass in 2 for 2 decimal places, then add standard fixed. This will display our balance up to 2 decimal places after the decimal point. So let's try that again. Okay, show balance, $123.00. If I were to change this to 123.01, we should display 2 decimal places. Yep, $123.01. Okay, that is the show balance function. Let's work on the deposit function. Okay, now we're within the deposit function. I'm going to create a local variable named amount. Set this equal to 0. We'll ask the user how much they would like to deposit. Standard output, enter amount to be deposited. Standard input, our amount. So I'm going to set balance back to 0. Then let's test it. Show balance. 1, your balance is $0.00. I would like to make a deposit. $420.69. Okay, now I would like to show my balance after we make a deposit. So within case 2, after making a deposit, let's show our balance, pass in the balance variable. Let's do so after a withdrawal too. Okay, let's try that again. Show balance, $0.00, make a deposit, $420.69. Your balance is $0.00. So what we're going to do is return our amount at the end of this function. Return amount. $420.69. All right, we have our balance. The user is able to enter in negative money. Enter amount to be deposited, negative 1,000. Your balance is now negative $1,000. We need to prevent somebody from making a negative deposit. So before we return our amount, let's use an if statement. If amount is greater than 0, then we will return the amount. Else, standard output, that's not a valid amount. Then let's return 0. Okay, let's try that again. Deposit money, negative $1,000. That's not a valid amount. Your balance is $0. I'm just going to add a new line, like right here. Then let's make a legitimate deposit. Deposit money. I will deposit $1,000.01. Your balance is $1,000.01. Okay, that is the deposit function. That is complete. Then we have the withdraw function. We'll create a local variable named amount of the double data type. We'll create a prompt, standard output, enter amount to be withdrawn, standard input, amount. At the end of this program, we will return amount. Okay, let's test it. Okay, I need to deposit some money first. I will deposit $1,000.01. Then let's withdraw money. I will withdraw $100.01. My new balance is $900, but we can overdraw our account still. So I'm going to withdraw $1 million and 1 cent. Our balance shouldn't be negative, so let's prevent our user from overdrafting their account. Within our withdraw function, let's add an if statement. If amount is greater than our balance, will display insufficient funds. Then we will return 0. Okay, I'm going to withdraw $1 million and 1 cent. Insufficient funds, your balance is 0. Okay, now what if the user would like to deposit negative money? Withdraw money, negative 1,000. Your balance is $1,000. We'll need to make sure that the amount is a legitimate amount. I'll add an else if statement. If amount is less than 0, standard output, that's not a valid amount. Now, else, we will return the amount to be withdrawn. Then within the else if statement, we'll need to return 0. There. Okay, let's withdraw money. Enter amount to be withdrawn, negative $1,000. That's not a valid amount. That's good. Let's withdraw again. I would like to withdraw $100. Insufficient funds. My balance is 0. Let's deposit some money. $99.99. Our balance is $99.99. Let's withdraw again. Let's try and withdraw $100. Nope, we can't. Let's withdraw again. $99.99. Your balance is 0. That's good. Then let's exit. Press 4 to exit. Thanks for visiting. Okay, so these functions are done. There's just one more thing we should add. If I type in some characters, like the word pizza, well, this will break our program. We'll want to clear the input buffer. So after our choice, let's add these 2 lines. Standard input dot clear function. So I haven't talked about this function. This function will reset any error flags when the standard input fails to interpret the input. Then follow this with flush. This is a function, pass in standard input. This will clear the input buffer. Basically speaking, once we hit enter, we have a new line character within our input buffer, so we just need to flush that and get rid of it. That should prevent our program from going crazy. So let's type in some characters. Invalid choice. Cool. Then I would like to exit. All right, everybody, that is a banking program for some practice. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's a banking practice program in C++. All right, everybody, in this video, we're going to create a game of rock, paper, scissors. Let's create our function declarations first. Char get user choice. Char in this case would be the return type. We'll be returning a character. Char get computer choice. Void, there is no return type. Show choice. There will be one parameter, char choice. Then the last function is void choose winner. There will be 2 parameters, char player, that's us, char computer. The computer's choice will be determined randomly using a random number generator. Let's define these functions. Let's copy all of these. After the main function, I will paste them, then add a set of curly braces after each. Currently, if I were to run this program, we do have some warnings because with these 2 functions, get user choice and get computer choice, we're not returning anything, even though we stated that we're returning a character. Just for the time being, I'm going to return 0, just so that those warnings go away, but we'll correct these momentarily. So we shouldn't have those warnings. Within the main function, we will declare 2 characters. One for player, char player, that's us, char computer, that's the opponent. We will take our player Then assign this a value of whatever is returned from the getUserChoice function. Then we need to fill in this function. Within the getUserChoice function, I will create a local variable of player as well. I'll create a message to begin our game. Standard output, rock, paper, scissors, game. I'll add a new line. This part isn't necessary, but I'm just going to add a bunch of asterisks afterward. Just because I think it would look cool underneath our title. Let's list our choices. Standard output, the character R for rock, new line. Let's copy this. P for paper, S for scissors. Standard input, player. I'm just going to test that this works. Standard output, player. Rock, paper, scissors game. R for rock, P for paper, S for scissors. I'll pick R. That would give us the character R. Okay, so we know that that works. I'm going to place some of this code within a do-while loop because the user might not type in R, P, or S. So, do while. I'm going to stick my code within the do-while loop. I'm just going to add one more line of output. Choose one of the following. All right, we'll continue this while loop as long as our player does not equal the character R and player does not equal the character P and player does not equal the character S. Then at the end of this function, we will return player. We can't escape this while loop until we pick either R, P, or S. That's how this condition works. Let's test it. Rock, paper, scissors game. Choose one of the following. R for rock, P for paper, S for scissors. I will pick W for wombo. Choose one of the following. R, P, or S. I like the letter X. Nope, can't pick that. Let's go with S for scissors. Okay, S is a valid choice. Okay, that is the getUserChoice function. That is complete. So I'm going to close out of this function. After we assign our player variable, let's display the user's choice. Standard output your choice, :space. Then we will invoke the showChoice function. showChoice. Then there is one parameter. We have to pass in a choice as an argument. We will pass in our player. That's a character. Within the showChoice function, I'm going to create a switch. Switch. We're examining some value against matching cases. We'll examine our choice argument that we receive. If our choice matches the case R, what would we like to do? I'm going to display some output. Standard output, just rock. Then I'll add a new line. Make sure to break. Then case P for paper. Standard output, paper. I'll add a new line. Then break. Case S for scissors. Standard output, scissors, new line. then break. Let's close out of this function, then test it. Okay, I'll type R for rock. Your choice, rock. P for paper. Your choice, paper. S for scissors. Your choice, scissors. Okay, the show choice function is done. Now we need to get the computer choice. Computer equals get computer choice. Then we'll need to fill in this function. Get computer choice right here. We'll need to generate a random seed. srand. Pass in the time function. Then type 0 or null. You may need to include this header file at the top of your program, just in case this doesn't work. Include c time. We'll generate a random number between 1 and 3. Int num equals rand function modulus 3 plus 1. We'll examine this number against matching cases. Switch. We're examining our num. The first case will be the number 1. If our random number is 1, let's return the character R. Since we're returning a value, we don't necessarily need to add that break statement. We're already breaking when we return. So we can omit this. Case 2, return the character P for paper. Case 3, return S for scissors. Okay, we can close out of the getComputerChoice function. That's all done. Back within the main function, let's display the computer's choice. Standard output, computer's choice. We'll invoke the showChoice function, but pass in our computer. Let's run it to test it. I'll pick R for rock. Your choice, rock. The computer's choice is paper. Let's try it like 2 more times. Okay, we chose paper. The computer chose rock. Let's pick S for scissors. Your choice, scissors. The computer's choice is also scissors. Okay, so the computer is picking a random choice. That's good. Now we'll have to decide who won. At the end of our program, we will invoke the chooseWinner function, pass in our player, as well as the computer. Then within the chooseWinner function, let's create another switch. We will examine our player against matching cases. If our player chooses rock, the character R, I think the best way to do this would be to use if statements within each case. If the player chooses rock, and if the computer chooses R for rock, that means there's a tie. I'll display that. Standard output, it's a tie. Then I'll add a new line. Else if the computer chooses paper, that means we lose. Standard output, you lose. Else, well, there's only one option left, scissors, because if the computer didn't choose rock or paper, that means they pick scissors. Rock beats scissors, so let's display that the user won. You win. Oh, then be sure to add a break at the end to break out of the switch. This is the case if the player chooses rock. Let's copy all of this code, paste it, and let's move this over. Now, if the user chooses paper, we have some different results. Paper beats rock. We'll change this line of output to be you win. If the user chooses paper and the computer chooses paper, that means it's a tie. It's a tie. If we choose paper and the computer chooses scissors, that means we lose. You lose. One more case. If the player picks scissors and the computer picks rock, you lose. Scissors beats paper, you win. Else, scissors ties with scissors, it's a tie. And that is everything. So let's close this function and run this program. Okay, I'll pick R for rock. We picked rock, the computer picked scissors, you win. P for paper. The computer also picked paper, it's a tie. I'll pick scissors. I picked scissors, the computer picked rock, you lose. Well, alright then everybody, that is a game of rock, paper, scissors. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's a game of rock, paper, scissors in C++. We have a big topic today. I need to discuss arrays. An array is a data structure that can hold multiple values. Values are accessed by an index number. Think of an array as kind of like a variable that holds multiple values. It's a little more complicated than that, but that's a good way of thinking about them. Perhaps we have the name of a car. This will be a standard string. I will name this car. Assign this a value of whatever car that you like. One car that I like is a Corvette. Then I will display whatever our car is. Standard output, car. So of course, this car is a Corvette. We can transform this variable into an array by making the following changes. After the variable name, add a set of square brackets, then enclose your values with a set of curly braces. There, we now have an array. My variable car is now an array. Now this variable can hold multiple values, multiple cars, kind of like it's a parking garage. Separate each value with a comma. This time I'll add a Mustang, then a Camry. Now take a look at this. I will display car. Now what the heck is this? So this is a memory address of where our array is located, like 123 Fake Street. If I need one of these elements, one of these values that's found within the array, in order to access it, I have to do so by an index number. After the array name, I will add a set of square brackets, then an index number. The first element in an array has an index of 0 because computers always start with 0. And we have our Corvette. It's kind of like a parking spot number. That's why I went with this example of cars. If I need the next element within my array, I would access element number 1. Then I should probably add a new line, just to separate these. New line. We have our Corvette and our Mustang. Then we have our third element, which would have an index of 2. So we have our 3 elements, our Corvette, our Mustang, and our Camry. You can reassign values too. I'm going to change the first element within this array. Take the array name, select an index number. I'll set this equal to a Camaro, a Chevy Camaro. Now at parking spot number 0, we have our Camaro, then our Mustang, then our Camry. I'm going to rename car as cars, just so people know that it's plural, although it's not necessary. One thing with arrays is that they can only contain values of the same data type. Like I'll try and stick a number within here. Number 1. So our compiler doesn't like it that there's a number in here with all these strings. So arrays should all be of the same data type. Now, if you don't know what you want to place within an array, you can simply declare an array, then assign values later. I'm going to declare an array of cars, and then later assign some values. Cars at index 1 will have our Mustang. Cars at index 2 will be our Camry. See, we still have an error though. Array size missing in cars. You can declare an array, then assign values later, we need to set a size to this array. It's a static data structure. If I'm only going to place 3 cars within this array, I'll set the size to be 3. So within the square brackets, you can set an array size. And this would work the same. You can declare an array, be sure to set the size, and then assign values later. Let's try one last example. I'm going to create an array of prices. These will be of the double data type. Prices, add a set of square brackets. I'll go ahead and assign these values right away, so I don't need to declare a size explicitly. Make up some prices. $5, $7.50, $9.99, then $15. I'll display these prices, standard output, prices. I'll list an index number of what element I'm trying to access. The first would be 0. Then I'll add a new line. Let's copy this line of code and paste it a couple more times. We have prices at index 0. That is the first element. Then 1, 2, and 3. And here are the prices. So yeah, that's an array. Think of it as a variable that can hold multiple values. It's a little more complicated than that. It's a type of data structure, but that's a good way of thinking about them. To change a variable into an array, after the variable name, add a set of square brackets, place your values within a set of curly braces. That's if you're assigning values right away. Or otherwise, you can set a size, and then assign values later. That's another option. So yeah, those are arrays. Your assignment is to post an array in the comment section down below. And well, yeah, those are arrays in C++. You guys ready? All right, let's talk about the size of operator. The size of operator determines the size in bytes of a variable, data type, class, objects, etc. Whatever you would like to find the size of, you stick within the parentheses of the size of operator. Here's an example. Let's create a double GPA. Our GPA will be a solid 2.5. To determine the size in bytes of my variable or a data type, I will just place within the set of parentheses. I'll display this. Standard output size of operator. I would like to return the size of my GPA variable. Then I'll just add a string. Bytes. New line. Let's take a look. The size of my GPA variable is 8 bytes. That's the maximum size allocated to my double variable. If I was to replace GPA with a data type, such as double, well, this would be the same, 8 bytes. This will be helpful in the future when we begin working with arrays. So let's try a couple other variables. I'll create a string, standard string name. Assign some name. Then I will find the size of the string. Size of name. The size of a string is 32 bytes. Because a string really just holds an address to where some text is located. The address of where the string of text is located is 32 bytes. Even if I were to change the size of the string, bro code is awesome. Well, this size is still going to be the same, 32 bytes. Because a string is a reference data type. Let's try a couple other examples. How about a character? Char grade. My grade will be an F. I will find the size of this character, grade. The size of a character is 1 byte. Let's try a Boolean. Boolean, student. Is somebody a student, true or false? I'll place student within the size of operator. A Boolean variable also takes 1 byte of memory. This time, let's find the size of an array in bytes. I'll create an array of characters. Char grades. This will be an array. I'll set this equal to some grades. A, B, C, D, then F. I'll place my array within the size of operator. The size of this array, grades, is 5 bytes. Remember that characters take up 1 byte of memory. An array of 5 characters would be, well, 5 bytes. We can use the size of operator to calculate how many elements are within an array. If we have the total size of our array, we could divide this by the size of one element. Size of grades at index of 0, or otherwise we can find the data type. will divide the size of my array grades divided by the size of a character. So I should have these many elements, 5 elements within my array of grades. If I were to add one more grade, like an E, even though that's not a typical grade, well then the total elements within that array would be 6 elements. That's a useful trick to calculate the size of an array, how many elements are within that array. One more, this will be a bonus question. I'll create an array of strings. I'll name this students. We'll enter in some student names, such as SpongeBob, Patrick, then Squidward. To calculate how many strings are within this array, how many students we have, we can find the size of my array students divided by the size of a string. I have 3 elements within this array of students. Then I could add one more. And this equation should calculate that. I'll add Sandy. Size of students divided by the size of a string would give me 4 elements. So yeah, that's the size of operator, everybody. It will return the size in bytes of a variable, data type, class, objects, all sorts of things. It will be really helpful when working with arrays because we can determine the size of an array, but we'll get some practice with that in the future. And well, yeah, that's the size of operator in C++. Alright guys, in this video I'm going to show you how we can iterate over the elements of an array. Suppose we have an array of students. These will be strings. Standard string. I'll name this array students. Set this equal to some student names. Pick a few. SpongeBob, Patrick, then Squidward. Suppose I would like to display all these students. Normally to do that, I would type standard output my array followed by an index number. So the first student would be SpongeBob, which has an index of 0, and my first student is SpongeBob. If I need to display all of the elements of this array, I would have to one by one access each element. Then I'll just add a new line. We have SpongeBob, Patrick, and Squidward. If I need to display all of the elements of an array, a better approach would be to use a for loop. I'm going to type for, parentheses, curly braces. We'll need an index, int I. I'll set this equal to 0 because the first element in our array has an index of 0. I'll continue this as long as I is less than the length of our array. Currently it's 3. Then increment I by 1. During each iteration, I would like to display each element. Standard output students. Now instead of an index number like 0, 1, 2, or whatever, I'm going to use my counter variable, I. Students at index of I. During the first iteration, I will be 0, then 1, then 2. Once we reach 3, we'll stop. I'll add a new line. This for loop will print the elements of my array. SpongeBob, Patrick, Squidward. There's one issue with this though. What if we add another student, such as Sandy? Well, this for loop will stop once I reaches 3. If we make any adjustments to this array, we would have to go into our code and make some changes, such as setting this for loop so that we discontinue when I reaches 4. This would work, but it's not the best solution. For our stopping condition, in place of just setting I to be less than some number, let's calculate how many elements are within this array. To do that, we can use the size of operator. I'll type size of my array. This will give me the total size in bytes of my array. To calculate the number of elements, I can divide size of students by the size of the data type, string, or even an element. This will loop through all of the elements of this array: SpongeBob, Patrick, Squidward, Sandy. If we change the number of elements, well then there's no need to touch this for loop. It will calculate the size automatically. See, now we just have SpongeBob and Patrick. Let's create one last example. I'll create an array of grades. Char grades. we have an A, B, C, D, then F. If I need to iterate over this array of characters, I would find the size of my array, grades, divided by the size of a character, the character data type. During each iteration, I will display grades at index of I, our counter. And this will display all of the elements of this array. So yeah, that's how to iterate over an array using a for loop. In the next topic, I will explain the for each loop, which has different syntax. And well, yeah, that's how to iterate over an array using a for loop in C++. Alright guys, the for each loop. The for each loop is a loop that eases the traversal over an iterable dataset. An array is an example of an iterable dataset. Suppose we're using a standard for loop, and I have this array of strings named students. We have SpongeBob, Patrick, and Squidward. Using a standard for loop, I would need 3 statements: an index, a condition, then we could increment or decrement our index. This does work, but there is another way of writing this using a for each loop. There's less syntax than a typical for loop, but it's less flexible. Using a for loop, we can go forwards, backwards, or even skip iterations of something we're iterating over. Using a for each loop, we start at the beginning and go to the end. There's less flexibility. So let's change this to a for each loop. First, we'll add the data type of what we're iterating over. We're iterating over strings. Then we'll need a name for the current element that we're on. We have an array of students. Let's name the current element student, colon, then our iterable data set, which would be our array. String student, colon, students. During each iteration, let's display whatever the current element is, which I named student. Then I'll add a new line. And there we go, we have our 3 students. Then you could change the amount of students if you would like. Let's add Sandy. Now we have SpongeBob, Patrick, Squidward, Sandy. Let's try a different example. Let's work with grades this time. These will be of the int data type. Int grades equals, make up some grades. 65, 72, 81, 93, good enough. The data type of what we're iterating over is not a string this time. It is an int, integers. Let's name each element simply grade, colon, the name of my iterable dataset, which would be my array, grades. For every grade in grades, let's display each grade. And here are the grades: 65, 72, 81, 93. So that's a for each loop. It's a loop that eases the traversal over an iterable dataset. There's less syntax involved in a for each loop, but it's less flexible. If you just need to display the elements of an array, a for each loop would work perfect. So yeah, that's a for each loop, everybody. Your assignment is to post a for each loop in the comment section down below. And well, yeah, that's the for each loop in C++. Alright everybody, so in this video I'm going to show you how we can pass an array to a function. Suppose we have an array of prices. These will be of the double data type. Double prices, straight brackets, equals, just make up some prices. $49.99, $15.05, $75, $9.99. Good enough. We'll create a function to find the sum of these prices and print a total. Let's say double total equals, then I'll invoke a get total function, which we still need to declare and define. So let's do that now. We'll return a double get total. Let's list the parameters. We need to accept an array of doubles, double prices, then add a set of square brackets for the parameter. Now, when we pass an array to a function, you only need to pass the array name. You don't need a set of square brackets. Then we'll need a function declaration. Let's do that before the main function. Then at the end of my program, I will display the total. Standard output. Pick a currency. Let's pick a $sign. Then I will display the total. Within the getTotal function, I'm going to declare a separate local instance of a total variable. Remember that variables can have the same name as long as they're within a different function. So we have double total. I'm going to iterate over my array using a for loop. Normally what we would do is say int I equals 0. I would continue this as long as I is less than. Then at this point, we would calculate the size of the array. But technically, this isn't going to work, and I'll demonstrate why. We have the size of our array, prices, divided by the size of either the data type or one of the elements. Typically, I like to use one of the elements. Prices at index 0, then I will increment our counter by 1 during each iteration. Within our for loop, let's assign total equal to total plus prices at index of I. Or we could shorten this to total plus equals prices at index of I. At the end of our program, we will return whatever the total is. Now, this isn't going to work the way it's written now. Here's why. When we pass an array to a function, it decays into what's known as a pointer, which we haven't discussed yet, but we will in future topics. Within this function, we're not working with an array anymore, we're working with a pointer that points to the address of where the array begins. This function has no idea how big this array is anymore. We can't calculate how many elements are within this array. What we could do is that when we invoke this function, we can pass in the array as well as the size of the array. Since this function no longer knows how big the array is, we can explicitly let the function know what the size is. So let's calculate what the size is. Int size equals, we can just copy all of this code, paste it. Now when we invoke this function, I'm going to pass the size as a second argument. Then we'll need a matching set of parameters. Int size. Be sure to add that with your function declaration too if you have one. I would like to continue this for loop as long as I is less than size. Now this should work. Let's verify that. Yep, and our total is $150.03. In conclusion, when you pass an array to a function, you only have to pass the array name. You don't need a set of square brackets when you do so. However, when a function receives an array, it decays into a pointer, and the function no longer knows what the size of the array is. So we could pass that as an additional argument to let the function know what the size is, which we could then use to, iterate over the array. So that's how to pass an array to a function. Your assignment is to post a function that accepts an array as an argument in the comments section down below. And well, yeah, that's how to pass an array to a function in C++. Hey, welcome back. So in this video, I'm going to show you how we can search an array for an element. Let's create an array of numbers. Something simple. Int numbers. This will be an array. Then assign some numbers. I'll just assign the numbers 1 through 10 because I'm basic like that. There, 1 through 10. We'll probably need this later. I'm going to calculate the size of the array. Int size equals size of my array, numbers, divided by the size of one of the elements. I'll just pick the first element. We'll need to keep track of an index, like what index did we find something that we're searching for? Int index. I'll declare this variable, but we don't need to assign it. As well as int my num. My num will be the number that we're looking for. Let's accept some user input. We'll create a prompt. Standard output. Enter element to search for. I'll add a new line because I can. Standard input my num. I'm going to create a function that will search an array for us. Let's define that function outside of the main function. This function will return an integer. That will be our index. The return type is int. I'll name this function search array. There's a couple parameters. We'll have 3 parameters. An array of integers, integer, array, the size of the array, int size, then some element that we're searching for, int element. Then we should probably add a function declaration at the top. That's good. This function will return an integer, the index of the element that we're searching for. We will take our index variable, set this equal to, then I'm going to invoke the search array function that we just declared, but we need 3 matching arguments for the 3 parameters that we have set up: an array, a size, and an element. We'll pass in our array, numbers, the size of the array that we already calculated, and the element that we're searching for. We're searching for my_num. Within the search array function, we will iterate from the beginning of the array to the end and see if there's any matches. We can do that with the for loop. We'll begin at 0, int I equals 0, that's our index. I will continue this as long as I is less than the size of the array that we're passing in as an argument. Then increment our index by 1. This would be technically a linear search. We'll start at the beginning and check every value until we reach the end. So let's check using an if statement within the for loop. If our array, we did name this array numbers, but remember that you can rename parameters. Numbers is technically our array. If our array that we receive at index of I, that's our counter, is equal to the element that we're searching for, we will return whatever the index is, I. If we search through this entire array and don't find that element that we're searching for, we'll return -1. In programming, -1 serves as a sentinel value. If you see -1, that typically means that something wasn't found. We'll return either I or -1, then assign it to this index variable within the main function. Using an if statement, we'll check to see what that value is. If our index does not equal -1, that means the element that we're searching for is somewhere within our array. Let's display the index. Standard output my_num is at index whatever the index variable is. Else, standard output my_num is not in the array. Okay, let's see if this actually works. Enter element to search for. Let's search for 1. 1 is at index 0. Remember that computers always start with 0. Enter an element to search for. Let's search for 10. 10 is at index 9. Enter an element to search for. 420, 69. 420, 69 is not in the array. For additional practice, let's search through an array of strings, such as food. We'll create an array of strings. I'll rename numbers as foods. Then think of some food that you like. Pizza, hamburger, hot dog. Int size equals the size of foods divided by one of the elements of foods. Let's rename my_num as my food. That's the food that we're searching for. And that will be of the string data type. In place of cin, when working with strings, let's use getLine because the user input may contain spaces. Standard, getLine, standard, input, my food. Within the search array function that we created, we will pass our array, foods. The size can stay the same. Then pass in my food. That's what we're searching for. Within the if-else statements, replace my_num with my food. Then we'll need to change the data types of this function. We're accepting an array of strings. Replace int with string. Do that with your element as well. Then we need to change the function declaration at the top of our program. Okay, we can now search through an array of strings. Enter element to search for. Let's search for pizza. Pizza is at index 0. Hamburger. Hamburger is at index 1. Hot dog. Hot dog is at index 2. Then let's search for something that's not within this array. What about sushi? Sushi is not in the array. Yeah, everybody, that is how to search through an array. This would technically be a linear search. You begin at the first element of an array, check to see if the values are equal. If they're not equal, you move to the next element until you reach the end. And that's basically it. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's how to search through an array in C++. Hey everybody, in this topic, I'm going to show you how we can sort an array. First, I'll explain the logic behind it, then we'll write a C++ program to actually handle it. We'll use a standard bubble sort. It's an easy sorting algorithm to write, although there are more efficient sorting algorithms. We're still learning, so let's stick with a bubble sort. So with a bubble sort, we begin at index 0, the beginning of our array. We'll examine the element directly to the right. If the element on the left is larger than the element on the right, we need to swap these two elements. I will take this element, move it within some temporary storage, like a temporary variable, take the element on the right, move it to the left. Take whatever's within temp, place it within that opening. Again, we take our value, examine the element to the right. If it's larger, we swap them. Then we would just repeat this until we reach the end. So that would be one element. We would repeat this process with the rest of the elements. Now for the next iteration, 1 is not greater than 9, so we leave it alone. Then we check the next element. 9 is greater than 2. We would swap these two values. I'll speed up the footage. That is a quick demonstration of a bubble sort. So let's actually write this in code now. Okay, let's create an array. This will be an array of integers. Make up some numbers, make sure they're not in order. Let's calculate the size of the array. Int size equals size of our array divided by the size of one of the elements. At the end of our program, we will iterate over our array. I'll use a for each loop. Int element in array. I will display using standard output every element, then I think I'll separate each with a space. Okay, and here's our array, obviously unsorted. So let's change that. I'll create a sort function, void sort. There will be two parameters, an integer array, int size. Let's add a function declaration at the top of our program. Before we print our array, let's invoke the sort function that we just created. Pass in our array as well as the size. There we go. Okay, so let's head to our sort function. What we'll need to do is iterate over our array once for every element that's within the array. We'll need the help of a temporary variable to swap some values. Then we'll need nested loops. For int I equals 0. We'll continue this as long as I is less than the size of our array minus 1. The reason that the condition is size minus 1 is because we don't need to compare the last element to anything. The larger values will naturally gravitate towards the end of the array. Increment I by 1, Then we'll need a nested for loop. Let's use index j because I is already taken. Now our condition is going to be size minus I minus 1. Once we place the larger elements all the way to the right, they should already be in order. We don't need to sort any elements that are already sorted. Then what we have to do is use an if statement to check to see if the current element that we're on, array at index of j, is greater than the element on the right, array at index of j plus 1. If the element on the left is larger than the element on the right, we just have to swap those two values. We'll take temp, which we declared up here, equals array at index of j, array at index of j equals array at index of j plus 1. Then lastly, array at index of j plus 1 equals whatever's within temp. And that should be it. Let's run this. Yeah, and our array is now sorted in ascending order. So if you need descending order within this if statement, use less than. And now this array is in descending order. Well, okay then everybody, that's one way in which you can sort an array. We used what's known as a bubble sort. It's easy to write, but it's not as efficient as some other algorithms that are out there. This is a good one for beginners. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's how to sort an array using C++. Hey everybody, in this topic I'm going to explain the fill function. The fill function fills a range of elements with a specified value. There's three arguments: a beginning address of a data structure, an ending address, then some value. Suppose we have an array of strings. Standard string, I'll name this array foods. I'll give this a maximum size of 10 elements. Then I'll go ahead and fill this array with the same food. I'll fill all 10 elements with the word pizza. So that's 1,
2, 3, 4, 5, 6, 7, 8, 9, 10.
So these all have the same value. Now this really isn't practical, although it does work. Just to demonstrate, I'll display the elements with the for each loop. We're displaying strings. For every food element in my array, foods, I would like to display each food element. Then I'll add a new line. So we have 10 elements all filled with pizza. You know, this does work, but it's not practical to initialize all of these elements manually. What if we had an array of 100 elements? I would have to type the word pizza 100 times. There's a few solutions, one of which would be the fill function, which would make this process a lot easier. I'm going to declare this array, but not fill it in quite yet. We have an array of 100 elements to store strings. I'm going to fill all 100 elements with pizza. So we type fill parentheses. Now we need the beginning address of a data structure. Well, that's simply the array name. Then an ending address. So that would be the second argument. We would type the array name plus the size of the array. So plus 100 in this case. Then some value. I'll fill this array with the word pizza 100 times. There we go. All 100 elements have been filled with pizza. Now, if you do change the size of this array, let's say we have 150 elements, you would have to go and change that within the fill method too. What I would do, in place of adding some number to my array, I will add a size variable. Foods will be index of size, and then we can set some size. Actually, better yet, let's make this a constant. Constant int size. Then I'll set this to be 100. Foods plus size. So again, all 100 elements are filled with pizza. Now here's a few exercises. If I'm filling the first half of this array with pizza, we have our beginning address. Then I need to find the halfway point. Foods plus size divided by 2. I'll just go ahead and put that within some parentheses for clarity. Then if I were to run this, the first half of this array contains pizza, and the second half contains nothing. It's empty. To fill the second half of this array with hamburgers, I would invoke the fill function again. We will begin where we left off. Foods plus size divided by 2. The ending address would be foods plus size. We will fill the second half of this array with hamburgers. There we are. The first half is all pizza. The second half is all hamburgers. Here's a challenge round. We'll fill the first third of our array with pizza, the second third will be hamburgers, and the last third will be hot dogs. But 100 doesn't divide by 3 evenly. Just to make this simple, I'll set our array to be 99 elements. We're filling the first third of our array with pizza, size divided by 3. Hamburgers will begin at foods plus size divided by 3, and end at size divided by 3 times 2. Then we'll invoke the fill function one more time. We'll continue where we left off, and we will end at foods plus size, and fill this with hot dogs. Here we go. So we have pizza, hamburgers, then hot dogs. So yeah, that is the fill function. We can fill a range of elements with a specified value. It's great if you have a lot of elements to work with, and you don't manually want to type all the values. If you would like a copy of this code, I'll post this in the comments section down below, and well, yeah, that's the fill function in C++. Hey, welcome back everybody. In this video, I'm going to explain one of a few ways in which we can accept user input and place it within an array. There's no one-size-fits-all way to do it. I'll show you one way that's good for beginners. Let's begin by creating an array. I'll create an array of strings named foods. We're not going to be assigning values to this array quite yet. That's where the user input will come in. If we're not assigning values right away when we initialize this array, we'll have to specify a size. For the time being, let's say 5, something small. Now arrays, they're static data structures. While our program is running, we can't change the size of this array. The max size is stuck at 5. And that might be a problem if we would like to enter in more than 5 items. We'll discuss dynamic memory in a future video. Then I'm going to calculate the size of this array. Int size equals size of my array foods divided by the size of one of the elements, foods at index of 0. Let's create a for loop to iterate over the elements of this array. For int I equals 0. We'll continue this as long as I is less than the size of our array, then increment I by 1. Let's create a prompt. Standard output, enter a food you like. Then I'll display the number to show the user what number we're on. I. Then I'm just going to add a colon at the end. If we're working with strings, we should probably use the getLine function, just because what the user enters may contain spaces. GetLine, standard input. We'll place our input within our array, foods, at the index of I, whatever we're currently on, our counter. At the end of our program, let's display a message. You like the following food. I'll use a for each loop to iterate over the elements of this array. We list the data type, a name for the current element, food in foods. Let's display standard output, whatever the food is. I'll add a new line, and that should be good. Now take a look at this. Enter a food you like. We're on number 0. I'm going to add +1 to I when we display our prompt. The user's not going to be sure why there's a number 0, but we know that's the beginning index of an array. So I'm just going to change that here. Enter a food you like. We're on number 1. Pizza, hamburger, hot dog, ramen, sushi, and these are the 5 elements. You like the following food: pizza, hamburger, hot dog, ramen, sushi. Okay, that's pretty good so far. Suppose the user only wants to enter in 3 elements, not all 5. We should add some way to escape out of this for loop, based on some user input. I'm going to add this line. Enter a food you like, or Q to quit. Now check this out. If the user types in Q, we would like to exit. if foods at index of I is equal to the string q, then I would like to break out of this for loop. The user is done entering an input. But there's a problem with this. Enter a food you like or q to quit. Number 1, pizza, hamburger, hot dog. Now I'm going to press q to quit. We don't have any more prompts to enter in food. We went to the results. You like the following food: pizza, hamburger, hot dog, q. I'd rather not put the letter q in my foods array. I'm going to create a temporary variable just to hold some user input. This will be of the string data type, standard string. I'll name this temp, meaning temporary. It's a temporary variable. In place of directly putting my user input into my foods array, I'll place it temporarily within my variable temp. I'm going to check if temp is equal to q, else we'll take foods at index of I, set this equal to temp. That way we're not directly assigning our user input to our array until we check what it is. If the user types in q to quit, we don't want to put that within our foods array. So let's try this again. It should be better. Enter a food you like or q to quit. Pizza, hamburger, hot dog, q to quit. Okay, pizza, hamburger, hot dog. Well, the letter q isn't here, but when we display what's within the array, we have these empty spaces. We did not assign a value to these. If one of our elements is empty, I don't want to display it. So we can make this following change. In place of a for each loop, let's use a standard for loop. Int I equals 0. Now here's the condition. We're used to saying I is less than size, right? I'd like to propose a change. We'll write a different condition. I will check if the current element is empty. Foods at index of I dot empty function. Then we'll add the not logical operator. We'll continue our for loop as long as the current element is not empty. Then we'll add the statement increment I by 1. We'll display our array foods at index of I. This for loop shouldn't display any elements that are empty. Pizza, hamburger, hot dog, q to quit. Yeah, and we only have 3 elements: pizza, hamburger, hot dog. One disadvantage of arrays is that they have a limited size. They're static. Once we declare a size, we can't change it. We're limited to only storing 5 foods. You could declare a larger size, but you may be wasting memory if a user doesn't want to type in alt10. So in future topics, we'll need to discuss both dynamic memory and vectors, which should be coming up sometime in the future. So yeah, that is one way out of many ways to enter in user input into an array. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's how to enter user input into an array using C++. Hey everybody, in this topic I'm going to explain multi-dimensional arrays, more specifically 2D arrays. It's an array made up of separate arrays. They're useful because they can represent a grid or matrix of data with rows and columns. Here's an example. I'll create a 2-dimensional array of cars, car names. The data type will be string. I will name this array cars. With arrays, they have one set of square brackets, but if you're creating a 2-dimensional array, you need 2 sets of square brackets. The first set of square brackets is for the number of rows. Let's say 3 in this example. The second set of square brackets corresponds to the number of columns. If we have 3 rows and 4 columns, 3 times 4 is 12, so that would give us 12 elements. If you're initializing your 2D array right away, you don't necessarily need to set a row size, but you do need a column size. I'll just set the amount of columns to be 3, just something small. Okay, so let's fill in the first array. This first row will be cars manufactured by Ford. I'll add a Mustang, then a Ford Escape, then maybe a Ford F-150. Okay, this is our first array. I'm going to create a second array. After the first array, I'll add a comma. What I like to do, I like to organize my 2D array kind of like it's a grid. So now we have a second array. This next array will be cars manufactured by Chevrolet. I'll pick a Corvette, then an Equinox, and a Silverado. Let's add one last array. These will be cars manufactured by Dodge. Challenger, Durango, Ram 1500. Alright, now to finish this two-dimensional array, we will enclose all of these inner arrays with another set of curly braces, then add a semicolon to the end. That is our two-dimensional array. You can see that there's rows and columns. In this example, each row corresponds to a manufacturer. So it's kind of like a grid, a matrix. Then if you were to access one of these elements, you need two indices. Just to demonstrate, let's display all of them. Standard output, cars. I need to select the row number, then the column number. Row 0, column 0. Let's see what car that is. I'm just going to add a space between these elements. Okay, row 0, column 0, that's my Mustang. Row 0, column 0, that's Mustang. Let's print the next element. That would be row 0, column 1. That is my Ford Escape. Row 0, column 1. I'm just going to zoom out. There. Then we have row 0, column 2. That's the Ford F-150. I'm going to display a new line character. Now we are on row 1. So let's copy these, paste them. Row 1, column 0, row 1, column 1, row 1, column 2. So this next row is our cars manufactured by Chevrolet. We have our Corvette, our Equinox, then our Silverado. Then we will display row 2, row 2, column 0, row 2, column 1, row 2, column 2. And these are the cars manufactured by Dodge. We have our Challenger, Durango, Ram 1500. So yeah, you can see that a two-dimensional array is kind of like a grid, made up of rows and columns. Now, if we need to iterate over a two-dimensional array and display the elements, here's one way in which we can do that. We can use nested loops. But just to make it easy, I'm going to calculate the amount of rows and columns that we have. Let's begin with the rows. Int rows equals size of my array cars divided by the size of one of the elements. Cars at index 0 is good. Then to calculate the amount of columns that we have, we could do something like this. Int columns equals the size of cars at index of 0 divided by the size of one of the elements. So remember, there's two indices this time. 0, 0 is good. In this example, we should have 3 rows as well as 3 columns. Now let's create a for loop to iterate over the rows. Int I equals 0. I will continue this as long as I is less than the number of rows that we have. Then increment I by 1. I'm going to display cars at index of I, just for the time being. Then for now, I'm just going to add a new line between each. So if I was to display cars at index I, that should give us 3 memory addresses, 1 address for every inner array. This memory address is for the first array, then the second array, then the third array. What I need to do now to get the elements within each array is to create an inner loop. Let's use an inner for loop to iterate over each element within each array. Int j, because I is already taken, set this equal to 0. We will continue this for loop as long as j is less than the number of columns that we have. Increment j by 1. Now I'm going to display cars, and there's 2 indices. I, then j. I'm going to display a space between each of these. Okay, now we have one long line of text. So once we escape the inner for loop, I would just like to print a new line. I'll add standard output new line character. Okay, and here's our two-dimensional array. The first row are for cars manufactured by Ford, then Chevrolet, then Dodge. That's how to iterate over a two-dimensional array. You have the outer loop that's in charge of the rows, the inner loop, which is in charge of the columns. So that's a two-dimensional array, everybody. It's just an array where each element is its own separate array. You have two indices, the first for the rows, the second for the columns. To access one of the elements, you have to specify the row, then the column that element is found. So those are two-dimensional arrays. Your assignment is to post a two-dimensional array in the comments section down below. And well, yeah, those are two-dimensional arrays in C++. Hey everybody, in this video we're going to create a quiz game using C++. Let's begin by creating an array of questions. These will be of the string data type. I will name this array questions. And then let's think of some questions. Really add any questions that you want. Here's a few that come to mind for me. What year was C++ created? Okay, that is the first question. I'll add an additional string. Question 2. Who invented C++? Third question. What is the predecessor of C++? And I couldn't think of a fourth question, so I'm gonna ask, is the Earth flat? Good enough. With each question, there will be 4 corresponding options. I think a two-dimensional array would be perfect for this. This will be a two-dimensional array of strings named options. We'll need to set the number of columns. 4 columns is good. This first array will be for the options for the first question. A will be 1969, B 1975, C 1985. 1985 is the correct answer. D 1989. Now we have our next array. Who invented C++? Guido van Rossum. He's the creator of Python, so that's not the correct answer. Bjarne Stroustrup. I'm sorry if I mispronounce your name, dude. Hopefully you're not watching right now. B is the correct answer in this case. C, John Carmack. D, Mark Zuckerberg. We're on question 3. What is the predecessor of C++? The correct answer is C. That would be option A. C+, C minus minus, or B++. Okay, last question. Is the Earth flat? Yes. No. Sometimes. What's Earth? Alright, then I just need to surround all of these arrays with another set of curly braces. And there is our two-dimensional array, named options, to hold all of the options for our questions. We'll need to create an answer key next. This will be an array of characters. Answer key array equals, here are the correct answers. C, B, A, then B. 1985, Bjarne Strostrup. C, the language C, that is. And no, the Earth is not flat. I looked it up on Wikipedia just now. Let's calculate the size of our questions. How many questions do we have? Int size equals the size of our array of questions divided by the size of one of the elements. Questions at index 0. We'll create a character to hold our guess. Int score to hold the score. Now we'll need to iterate over our questions. Let me move down here. Int I equals 0. We'll continue this as long as I is less than the size of our array, the size of questions. This would effectively be the amount of questions that we have. Then I'm going to increment I by 1. We will iterate once through all of the questions we have. Standard output. Let's access the string that's within questions at index I. I'll add a new line. Just for some text decoration, I'm going to add a bunch of asterisks before and after the question. So let's get rid of this. I think that'll look pretty cool. There we go. Then we'll need to iterate over our 2D array. We'll use an inner for loop for that. We'll need a different index. I is already taken. Let's pick j. Int j equals 0. We'll continue this as long as j is less than. Now we'll need to calculate how many elements are within each array. So we can do that with size of our options array at index of I divided by the size of options, and there's two indices here, I, then 0. Then we will increment j by 1. We will display our options, standard output. Options, there's two indices, I, then j. I'll add a new line. So if I were to run this, this should display all of the questions and all of the options. Yeah, here we are. What year was C++ created? Who invented C++? What is the predecessor of C++? Is the Earth flat? After all of the options are laid out, we will accept some user input, standard input. We will place the user's input within guess. Then just in case the user types in something that's lowercase, like a lowercase c, we're looking for capital C. So let's take the user's guess, then make it uppercase. Guess equals to upper, pass in guess. So that will capitalize the character the user enters in. Then let's check to see if the user's guess is equal to the answer. We'll need to access the answer key at index of I. That's the current numbered question. If those two values are the same, we will display correct. I'll add a new line, then increment the user score, score plus plus, else the user's guess is not correct. Standard output, wrong. Then we will display the correct answer. Standard output, answer, colon, space. We'll access the answer key at index of I. Then I'll add a new line. Okay, let's try this so far. What year was C++ created? C. Who invented C++? That would be B. What is the predecessor of C++? That is C, the language C, but it's option A. Is the Earth flat? What's Earth? D. Okay, wrong. Answer B. Okay, so we know that we can cycle through the questions. Outside of the for loop, we will calculate the player score. So right here, I'll display the word results, standard output, results. I'll add a new line. Actually, now that I think of it, I'm going to steal some of these text decorations. Let's make it look pretty. Something like this would look cool, but not necessary. Standard output correct guesses. Then we will display the current score. Add a new line. Standard output number of questions. That is simply the size of our array. Add a new line. Then we will calculate a percentage. What percent of the questions did they get right? Score divided by size times 100, then we'll add percent. So at first, this isn't going to work because we're using integer division, but I'll explain that momentarily about typecasting. So let's run this once. Let's say A, B, C, D. Correct guesses, 1. Number of questions, 4. Our score was 0%, even though we got one right. We'll need to add a cast to the divisor. Let's cast size as a double to hold that decimal portion. Then this should work. A, B, C, D. Correct guesses, 1. Number of questions, 4. Our score was 25%. Now let's go for 100. Remember that the correct answers are C, B, A, B. 1985, Bjarne Stroustrup. The language C, but that's option A. Is the Earth flat? No. B. Correct guesses, 4. Number of questions, 4. Score 100%. Well, yeah, everybody, that is a quiz game you can make in C++. You can impress your friends or have your friends take the quiz. You know, you can change your questions around if you want. If you would like a copy of this code, I'll post this in the comment section down below. And that is a quiz game written using C++. Hey everybody, welcome to the exciting world of memory addresses. A memory address is a location in memory where data is stored. In C++, a memory address can be accessed with an ampersand, known as the address of operator. Suppose we have some variables. I'll create a string. The variable name will be, well, name. Assign this a string of text. I'll create int age, set this equal to some value. Then a boolean. Boolean, student, I'll set that to be true. A variable is a container for some data. But these variables need to exist somewhere. Well, they exist in your computer's memory at a given address. We can find that address with the address of operator. I'll display that. Standard output. I would like to display the address of name. Then I'll just add a new line. Here's the address of my name variable in my computer's memory. It's a bunch of weird letters and numbers. Well, this is a hexadecimal address. Every time we run this program, that number is likely to change. Let's display the addresses of age and student. Address of age, address of student. Here are the memory addresses. Again, all in hexadecimal. So these are kind of like street addresses. Hey, for fun, let's decode these to decimal. You can easily find tools online to convert hexadecimal to decimal. Let's see what these numbers are. Here are the hexadecimal memory addresses, but converted to decimal. They're like house numbers. Different data types take up more or less room than other data types. If we look at the distance between my name variable and age, well, that has a gap of 4 memory addresses, but the gap between my age and student variables is only 1, because, well, booleans only take up 1 byte of memory. That's one of the reasons we use data types. We need to know how much memory we need to allocate to fit a certain value. If we're working with